is actually a synchronous framework for connected systems. That's the title of the talk. However, I realized that if I add distributed microservices and blockchain, it's way more attractive for people. So this has nothing to do with blockchain, but then everything has to do with blockchain nowadays. Now, I went to my local supermarket, I kid you not. I kid you not. Like, this is a local supermarket. And there was a big sign, a pull-up by the door. You know, one of these roll-ups. And it said, download our app and verify the origin of your product using blockchain technology. It's like we're in IT and we don't know what blockchain means. You think your average consumer knows what blockchain is? So even though this session has absolutely nothing to do with blockchain, it has everything to do with blockchain. If you want to use Ktor, your manager doesn't buy into it, say blockchain. They're done. The crazy thing is that it works. Anyway, what is Ktor? It's not blockchain. It is for server-side development. Ktor is actually an application that we started, a framework that we started some time ago. And it's for server-side development. It is also client-side libraries. So it's not just for server-side, it's also client-side. It is multi-platform, not all of it, but the client-side, there's parts that are multi-platform, and then the server-side, we're working to make it more platform. It's Kotlin through and through. So although it relies on the JVM for certain things, etc., all of the code is written from scratch in Kotlin. And it is asynchronous. So it is using coroutines, and it's got an asynchronous execution model. Ktor is also open source, also known as free, right? Because we love the open source part. We love the free. Yeah, never mind. It is built and maintained primarily by JetBrains, by us, and of course external contributors. So it is also inspired by many other frameworks such as Wasabi and Kara. Wasabi was a framework that I started a few years ago, which was essentially, I did some Node in my life at some point, which is Node and JavaScript. And I used to work with a framework called Express.js. I don't know if anyone's heard of it, which was kind of based on Sinatra, which came from Ruby. And at the time, Ruby used to have Ruby on Rails, and then they did a lighter weight framework called Sinatra, and then the JavaScript folks created Express.js, and then there was Happy.js. And Wasabi was my attempt to do Express.js on Kotlin. And I started in the my mic keeps going. In the early days, and then, then we needed to port it to coroutines. My colleagues had started Ktor, so I kind of like, they did a hostile takeover of Wasabi, and now it's Ktor. Kara came about around the early days of Kotlin, and Kara was the equivalent of Ruby on Rails for Kotlin. So it was an MVC, it had a model view controller approach, and that was Kara. Recently, I saw a new GitHub project that had been created, which is creating an MVC framework on top of Ktor. So we're essentially full circle now, right? Ktor can be used for many things, such as server-side applications, which include HTTP APIs. Now, HTTP APIs, how many of you know, how many of you do REST? Okay. Keep your hands up. Don't rest it. You can also do RESTful systems. I always find this interesting because those people that put up your hands, how many of you are using hypermedia in your RESTful systems? Okay, pretty much nobody. So then we're all doing HTTP APIs. Because actually a RESTful system is not just HTTP with JSON. One of the core aspects of RESTful systems is that it complies with the idea that you use hypermedia as the engine of application state. But nowadays, much like blockchain, you don't go to your manager and say, I'm going to create an HTTP API. You say, I'm going to do REST. REST sounds so much better. You could do socket programming, And then you have, of course, client-side connections, which I spoke about. What are the goals of Ktor? To be simple. I wonder if there was ever any language, framework, or anything that was created and the first goal was, we want to make this as complex as possible. And they would sell that. They're like, what are the goals of this framework? To be complex. I mean, would I even put that on the slide? Yes, Ktor is to be complex. Flexible, to be really, really inflexible. Yeah. And what is the other one that's going to pop up? Performant. Right? So, like this slide is just speaks for itself. I don't even need to talk. Cross-platform. I took out all the bad stuff and I made a slide with the good stuff. No, but this is all true. We try and be simple, flexible in that we do not dictate a specific way that you have to do things. This, of course, has many advantages. It also has some disadvantages because there's multiple ways often that you can do this. So the framework gives you that flexibility, as we'll see. Performant, yes, because we're never going to try and create a framework that's not performant. We run external benchmarks against this test benchmark or whatever, so you can see the results there. And cross-platform, as I mentioned, the client-side stuff is there. The server-side is coming. So let's take a look at a simple server. This is the basic that you can get up and running. So I have a function main, and here I have an embedded server. And we'll get to that in a moment. And it's using, under the covers, it's using Netty. And then I have a routing, right? So here I've created the server. The next step, I have a routing. So this routing is, or routing, depending where you're from. So I have a routing, and then I have the slash, which is the root page, the home page. And all I'm doing there is saying, respond with text, hello Ktor, content type text HTML. Now, that's actually a bug. But again, I'm doing it so you pay attention. Because that is text plain, essentially. I'm not responding with HTML. Now, a Ktor application consists of multiple modules. So you can actually kind of create different, you can create a Ktor application that consists of like 6 modules, and these modules may have different things to do with different areas of your application. Normally, though, generally, you probably have an application with a single module, and then you can have multiple Ktor applications, each of them having 1 or 2 modules. And modules are nothing to do with controllers or anything. We'll see that in a moment. So the way that it works, the module essentially has a request that comes in, and it goes through a routing mechanism. Then it has a series of things that can happen after that routing, which are called, for example, they could do some encoding, it could do some compression or what have you, and then it goes to your application logic. And that's where you do the heavy lifting stuff, right? Access my database, do X, do Y, and then push out the response, right? Very, very simple pipeline of request to response. Now, those little things that I showed you, compression, etc., these are actually called features. And the features that you see here, the encoding, all of these are actually features, but routing is also a feature. So it's extremely flexible that routing in itself is also a feature of Ktor. It's not just something it is built in, but you don't necessarily have to use it. It is just a feature that comes with it. Generally, though, if you're doing HTTP, you're going to be using a routing mechanism. But the point being is that Ktor itself is very simple, and every functionality that you see there is a feature. And these features can be placed in different places during the whole request lifecycle, request-response lifecycle. So it could be at the very beginning, it could be at the very end, it could be before routing, it could be after routing, and then you can have priorities and orders between these features as well. Okay, so very kind of flexible in that sense. Okay, so now let's switch over and see some code. Right, the first thing I want to show you is start.ktor.io. Okay, so how many of you ever use Spring? Okay, so in Spring you go to start.spring.io and you have this kind of web page that allows you to generate a project and add a series of functionality to it. This is essentially the same thing. I can come here and I can say I want a Gradle project, a Maven project, I want the different type of engines, what type of my group name, etc., and then the different features and add-ons that I want to use, and whether I want to do server-side, client-side. Once I do that, I download it, and away I go. And I've got my Ktor application. Or I can install the IntelliJ plugin. So in the IntelliJ plugin, essentially, I say File, New, Project. You see that I have this Ktor over here, and then I have HTML, static, a whole bunch of different things which show you add a series of different features that are available. So I'm just going to click static content over here, click next, example. By the way, Swagger. Does anyone use Swagger? Okay, I'm not a fan, but if you like it, fine. And I'll create my Ktor application, and away I go, and I have my Ktor application. So it's created this, and we can wait for the internet to download everything that is required, and it doesn't want to. And that's why I have a pre-made Ktor application for you. No, actually I know why that happened, because there is, believe it or not, a bug in the plugin. I'll show you. Do static content, routing, it's there, and let's do some HTML. And we're going to do this again. And if this doesn't work, then I'm just going to leave. Just going to leave. Yep. There you go. See that? Whoa! Look over there. Yep. And here's the application. That's why I showed you the web page, because you can also generate that on the web page. I know. If only I could use a good IDE. Oh, okay. So let me show you how this works. I've got a whole bunch of applications here that I'm going to show you how this works. The default one is the one that we saw in the slide. So generally, when you want to create a Ktor application, you're going to create a main entry point, and then you're going to define everything in that main entry point, and you're going to execute that main entry point. So all of the configuration for that server application would be defined in code. And you can do that, right? Like the port, etc. But in real-world applications, you don't want to be hard coding configurations inside the application itself. What you do is generally use a configuration file. So in Ktor, we use this concept, this file, which is called HOCON, which is like human-oriented, readable JSON, or something like that. And you see that I have my deployment information, so the port, the actual, I can also define a system port if I want to, and then I define the list of modules that my Ktor application is going to load. Remember that I said a Ktor application can have one or more modules. In this case, I only have a single module. If I wanted to load more, I would just separate them by commas. Okay? Now, these ones over here that you see are all commented out. Usually, you don't do this, but I'm going to run through a whole bunch of demos. So I've commented out the ones that I'm not going to be using at a specific point of time, so that you don't have to watch me type. So in this case, I'm going to launch a simple application. And if we take a look at the code for the simple application, this is very, very simple. I have this application.simple, so this is my module. And then inside there, I'm defining routing, get, homepage, respond text, hello world, Kotlin text plain. Now, what is call? Call is actually part of a Kotlin object, which is the application call. So normally in any kind of framework, you have an application, you have a request and a response. In Ktor, you have that. It's part of the call. So the call has a request object and the call has a response object. That's how you access all of the parameters, and that's how you respond to all of the requests. Given that this is an extension to application, I have access to the call. The routing is essentially just a routing function that adds a certain routing configuration to the routing table. So this is what I was showing to you about the whole DSLs, how you can easily create DSLs, how you can easily create scripts, and Ktor is an example of it's doing this. So here I say get, respond text, and away we go. Now let's go over to my application, which is this one over here, and hit run. Now, look how fast this boots. Build, and it's booted, right? It's already started. So if you've used some other frameworks, you know that some of them have a delay in terms of booting. This one is already started. I can click on the URL, and I get my hello world. Okay? So that was the simplest example of getting your application server running. So what else can we do? So the next example we're going to show you is how we can actually create some static content. Because generally, you want to return a response, but you also want to be able to serve some static content. So here's the example of static content. As simple as that. So essentially, I'm saying I have a routing, and then I have static content, which is hosted in /static. And then from there, anything that is defined in resources can be loaded as static content. So if I look at my application, I have here my static content in the folder static. Okay? So really, if I just want to load static content, I just say the path, and then I can load that. So let's run this one. So notice that I've not changed anything about the application. All I've done is essentially changed the configuration file. I've just changed the module that is loading in this case. And then here I should be able to do static Ktor logo, and I have my logo running. So as simple as that. You want to load static, you just say the path, where that is in terms of resources in your project file, and you can start loading all of your static content from there. Next example, HTML. So in the first example that you saw with the simple, you saw that I was essentially returning context text plain. Now I could say HTML over here and embed HTML in my string. Obviously that's completely possible. But why do that when you can make use of Kotlin X HTML? Have you heard about Kotlin X HTML? Yes? So that's essentially Kotlin X is some extensions that we provide to the standard library, and there's an HTML which essentially provides you with the ability of having static typing HTML with Kotlin. So this body, H1, UL, all of this are essentially part of the HTML library. They're all functions. You can navigate to them. You can get completion, everything that you would potentially want. Similar to what I was showing with React, with the React application, where I said that this isn't JSX, this is Kotlin X HTML. So here, I'm essentially saying I'm going to respond HTML. Instead of calling the function, I'm going to call the higher order function overloaded version that I have of that, and then just return the contents of that HTML. Now, of course, this is Kotlin code. So this is Kotlin. So that means that if I'm, for example, serving data from a database or serving from records, I can have my for loops, I can have my for each, I can have my function calls, all of that intermixed with HTML. Some people, when they look at this, or when they look at React Native, sometimes they have some pushback. And they say, wait a minute, didn't you spend 30 years of my life explaining to me that I should do a separation of concerns and that I shouldn't mix like business logic with data access with HTML, with CSS, etc., etc.? Yes and no. Because separation of concerns can also be separation of concerns in terms of the application logic, in terms of the feature, in terms of all of these. But you can still combine these technologies. Nobody said that the separation of concerns has to be specific to the framework library technology that you're using. But each person is different, so use it at will. So if I run this one, and again, notice that I'm not changing anything. I just stop the server. And I stopped the server because I didn't choose the correct application config file. So this one is HTML. Yeah, I did it correctly. I launched this, and in this case, I'm going to get back. No. Oh. /HTML DSL. Okay? There you go. So very simple. So now we know how to create static content. We know how to create text, and we see how we can create HTML. What do we have next? Posting. So far, basically what I've shown you is get. What if I want to do some posting? So here I have a routing table, again, and the get is going to respond with HTML. And if you look closely, all I'm essentially doing is defining a header, an HTML page with a title, and then some body, and then a form action. But notice something which I'll show you how to resolve later on, which is here I'm using action form, and then a bit of, you see this form here, and then there's this form here. So it's a little bit strings going on here and there, okay? And we'll see how we can make this in a different way soon. And then I have a get, as we saw, and then I have a post. Now the post is going to actually submit. When I submit, it's going to post that information. Now notice that I have support already for certain things that are provided in HTTP, which is multi-part. So if you've ever done a multi-part form application, what that is that it's essentially a form that has text combined with binaries that you can upload files. So all of that is already supported in Ktor, much like chunk transfer, etc. So here I say, open up, check to see if it's a multi-part request. If it is, if it's not, then return a response. If it is, then for each of these, do different actions. So for each part, if it is form item, then I respond, adds a specific line for the response. If it isn't, then I will parse the file and then add to the response the actual file name. And the append line is essentially this respond text writer object that I've opened, where I can continuously add content and then respond with it. Okay? So let's run this one. And this is going to be the root. So if I call the root, I see the form. So I say, for instance, hello. And then I can choose a file. So let's go over here and say, for example, the brochure, and then send. And you can see that it shows me the response where I have, for the field, I have the hello. And for the actual file that's been uploaded, I can access the file name. And of course, I've got the binary available as well if I want to access it, right? Otherwise, it would be of very little use. So post is supported, multi-part form is supported, and you can notice here that if we go back to the code, the value is the field name. So I'm accessing it, so it's doing the smart casting already. It knows it's a form item and then gives me direct access with completion to the actual form name. Okay, what next? Now, some of these things that I've been showing you are actually features, including what I mentioned around the routing. So let's take a look at some other features. So the way that you work with Ktor is that if you want to use a feature, you essentially install it. And a feature here is, in this case, I'm installing two features. One of them is called default headers, and the other one is called compression. Now, a feature in itself consists of two parts. When you develop a feature in Ktor, you have two parts. From one side, you have the actual runtime behavior. So, for instance, if I'm creating default headers, the runtime behavior of that feature is to intercept the response and send back some default headers. And then you have another part of it, which is the configuration. So this is the configuration of the feature, except in this particular case, there isn't much in terms of configuration. I just install the feature. Later on, when we see another feature, such as JSON, we'll see how we can add some configuration to that as well. But remember, the feature is always two parts: the configuration, the initialization, setup, and the actual behavior. So here I'm doing install default headers, install compression, and then again I'm doing my routing, and I say get headers, respond, and check the headers. So that's just going to essentially respond to me with check the headers, meaning I got to open up the browser and check the actual headers. So let's go ahead and run this one. Okay, I just want to make sure I got the right module. Yes, we do. So we'll open this up, and then we'll do headers, and it says check the headers. So let's see the network, and we can check the headers, and we can see that it's added a bunch of request headers, which by default wouldn't be sent in Ktor. Okay? And all it is just essentially adding a single line telling me what feature I want to use. Right, next. JSON. So this is an example that I said that you can have certain level of configuration. So in this case, I'm installing content negotiation. Now, content negotiation, what it does is essentially provide that feature where you can return different types of content based on the media type selected. So when you send an accept header in HTTP, what that does is it goes to the server. Generally, you know, if you're sending an accept header in HTTP, you're going to be doing something like send application JSON, right? And then a lot of the headers have this parameter like Q01. I don't know if you've noticed. That's actually called the wait. And a lot of requests when you make to a server, you say application/JSON, comma, application/XML, comma, application/plain text, or text/plain. And what does that mean? That sends a message to the server saying, I'm accepting all of these types of responses, and my order of preference is denoted by Q. And by default, Q is 1, right? Q is the wait. So when I do an install of content negotiation in Ktor, what it's going to do is actually install this ability. It means that when a client sends a request and says, I want application JSON, it will respond with application JSON. If the server does not support application JSON, then it will respond with the next option. And if it does not, it will just respond with a media type not supported, which is the HTTP status. Now in this case, I have some configuration for this feature. What I'm doing is installing JSON. And JSON, or JSON, is the serialization library that is available, which is called JSON. And that has a series of options, such as set pretty printing, serialized nulls, etc. So out of the box, we support JSON, we support Jackson, and we support Kotlin serialization. Okay? So I'm saying, in my case of JSON, I can support set pretty printing, and then I've got different options here. So let's say set date format, set all of these things that are specific to JSON. Then in the routing, what I'm doing is creating an instance of a customer and then just saying respond with model. Nothing else. I am not converting it to JSON, nothing. I'm just saying respond with the data class. And what Ktor would do here is essentially see if the request comes in as application JSON and then respond with that, automatically doing the serialization. So come here and then do customer, and we can see that I'm getting some JSON back. And of course, if I have a collection, then I get a collection with an array and then the items. Right. Application config. Authentication. We support many mechanisms of authentication. So you have support for basic authentication, you have support for OAuth, and a bunch of other pluggability features that you can do to whatever type of authentication that you use. Obviously, there's form authentication, etc. as well. In this case, what I'm doing is I'm installing basic authentication. So here again, I say authentication, install the feature authentication. In this case, I want basic, and I can have multiple types of authentication. I'm setting the realm, which is something you generally set, especially with basic authentication. And then I provide a validation function. This is extremely, don't use this in production, obviously. But what I'm saying here is that when the credentials come in, check that the name is equal to the password. If it is, then set the principal. Set the ID for that user. In this case, I'm saying credentials name. Otherwise, return null. Now authentication is in place. It's configured, it's basic. How do I actually use it? So here I have two entries. One of them is called get, which is the home page, and then another one which is called authenticate. Auth and then get secure. So what this means is that anything that's in this block authenticate requires authentication. And which authentication does it require? Auth. And what is auth? Here. So if I have two different types of authentication in my application, I can easily do that. I just create two different blocks and the different roots in each block, and then each of these are correctly mapped to each specific block. So if we go ahead and run this, you can see that if I enter the home page, it works. And then if I go to secure, it's going to ask me for my prompt. If I hit cancel, it won't work. If I refresh and say ABC, ABC, then it will show me the secure area. Okay. Are you following? Are you liking? I heard someone say no. Like, really? Okay. Custom feature. Ktor already comes with a whole bunch of features. I've shown you that in the. You can even go to Ktor.io. By the way, if none of this convinces you to use Ktor, the domain should. It's .io. It's like you know it is hip. So if we click on servers and we click on features, you can see all of the different features that are provided. Authentication, auto head response, caching, caller ID, content negotiation, cores, date. Like there is a ton of stuff already supported. But if something that you want isn't supported, then you can make your own custom feature. So this is what I was talking to you about earlier on. A feature consists of two parts, the configuration and then the actual behavior at runtime. So in this case, my configuration is essentially a header name and a header value. And then the actual implementation is the intercept function, which is basically intercepting the code and adding some custom headers. In order to use this, I do install custom header, I set the name, the value, and that's it. So it's exactly the same as install default headers, except in this case, I have that extra configuration in the initialization, much like we had in the case of the content negotiation feature. Okay? And these parameters are what's defined in this nested configuration class, which belongs to the feature. So, I mean, we don't really need to run this one, but if we do, we can see that this is going to give me back the custom headers. So you see that I have some header over here, response headers A, B, C, D, E, F. Okay? Sometimes you see that it does take a couple of seconds to load. That's why every time I click the browser launches too quickly, and when I hit it, it doesn't load. I should just talk slower, and then you'll never see that error again. Now, the next routing. So I've shown you a whole bunch of demos, and all you've seen is essentially this application object that I'm extending, and inside there, I'm adding all of these routing. So if you take a look at, for instance, this post, this already starts to become quite long. And if you have an application that has, you've got your customer, you've got your employee, you've got your invoices, you've got all of these things, obviously you don't want to have all of this in a single file, because then it becomes a little bit painful. So you can do different types of routing, and one of the things that I mentioned initially, I said that Ktor is very flexible, is that it allows you to be very flexible in how you try and do these routing, right, and where you place them. So the first step, and then we'll see how we can separate these, the first step is that I can do nested routing and group routings. So for instance, here what I'm doing is I'm creating a routing, and then I have a get, And then I have another root, customer, and customer in itself has a get and a post. I have another one that is root employee that has a get, and then I have a shipment that has international and national roots. Notice already that I'm using some other things here. So in the customer, I can do query parameters ID. So the query parameters is essentially the question mark ID equals 10. That's how I access the query parameters, using the call.request.query parameters. In this one, I have curly braces ID and parameters ID. What is this one doing? This is accessing a variable in the root, a parameter in the root. So whereas the first one is ID question mark ID equals XYZ, this one would be employee / number. Right? So one is part of the root, the other one is a query parameter. So let's try and run this one and see if we can get it to work. No, we can't, because the other one hadn't stopped, I guess. Okay. What is this package? No. Hold on. Oh, I know what the problem is. This is routing app. I got the name wrong. So this should be routing app KT. The reason that this is KT is because I've put these in a file, and by default that generates a package name. If I don't give it a package name, the same name as the file, KT. That's the default behavior in Kotlin. So let's run this again, and it still doesn't want to work. Now what's the problem? No Ktor blah 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 could be found. Routing app KT, routing app. I wrote that. Oh, routing app. Oh, package. Hold on a second. Routing app KT. Where are we? Routing app KT, routing app. That should work. If that doesn't work, I quit. I quit. Routing KT. Oh, yeah, we'll find that. Sorry, yeah, sorry. Hold on. Stupid me. Thank you. Aha. Okay, routing demo. So now if we go back to the source code, which is routing, we see that we have customer ID. So if I do, for example, customer ID equals 10, that will show me 10, right? And if I were to do, the other one is employee, so employee 30, that would show me employee 30. So one is query parameter, the other one is part of the root. But what this does is also allow me to group the different roots. So now I can group like the customer. So let's say, for instance, that you have, if you've done any kind of MVC, or if you've done any kind of Spring development or Spring Boot, that root segment over here, that would be kind of equivalent to your customer controller. Right? You would group it into a customer controller, and then you would have all of these entries with get, post, put, delete, etc. This is the flexibility of Kotlin, in that here I'm doing it as roots. I could do it as customer / get or what have you. It's completely flexible in that sense. And that takes us to the next one, which is how do I actually configure this stuff in a way that would be nice for me to scale my application. And that's where app structure comes in. So this is, again, very flexible in how you can do it, but one convention and one way that we generally do it at JetBrains, and we kind of recommend, is that essentially you would have a file, for instance, for each type of concern. So if I had something around employees, I would put that in an employee routing file. And then what you do is, instead of having to define routing and then get, etc., you can just make every route or every URL request, however you want, an extension to root. As soon as you do that, then you get access to all of the properties and functions of root, and then you can scale your application nicely. You can have each of these in different files, and not have to do routing every time. Very, very flexible. But take into account that at the end of the day, routing is just a function. So all you need to do is just return the same thing as routing returns, and you've configured your routing table. So in this case, I would put this in 2 different files. I would have home, and then here I would have everything to do with home. Here I would have everything to do with employees. But I don't even need to put everything inside a single function. Because if this were in a different file, then I would have home, home about as different functions, or I could even have those in different files. It really is that flexible. You're not constrained to saying customer controller and everything under the path customer has to fall into that controller. In fact, I'm not even using classes in Ktor. Now, if you want to use classes, you're more than welcome. So if you want to do less functional, more object-oriented, you can use classes. You can inject your dependencies. You can have an IOC container. There's, in fact, a feature that you could do to essentially inject the IOC container during the initialization. So all of that is possible. It is very flexible in that way. So this essentially what it's doing is when I do routing home, home is returning that function that defines those routes. Okay? We don't really need to run this one. You can trust me that it works. Now, one thing that we saw earlier on with the post, which I mentioned, is I have a form here. I'm reusing that. So I'm essentially using strings. Now, granted that with any, with IntelliJ, for example, if you do some refactoring, and you rename form to form A, it gives you the option of, do you want me to search for some strings and provide you refactor the strings as well that you've updated. But wouldn't it be nice if we could get some static typing here? And that's where locations comes in. So locations is essentially allowing you to define URLs in a statically typed way. And this gives you some benefits. First of all, you get static typing. You don't get the strings everywhere. Second of all, it gives you better completion for the actual properties, the query parameters or the form parameters being passed in. The reason that this is in yellow or green or whatever is that locations is still somewhat experimental feature of Ktor. One of the things that I personally don't like is that we've called it location, which really is misleading, especially when dealing with HTTP, because HTTP has the header location. Right? Are you familiar with the location header of an HTTP? I'll give you a perfect example of where you can use an HTTP header location. Let's say that you do a post to an HTTP server. What is post? Post is essentially creating a new resource, right? That's what post does. So let's say that you post some data and that creates a record in the database. You often have the need to pass back the ID of that record that's been created, of that resource. That's what the location header in HTTP is for. That's exactly how it's defined in the RFC. So one way to implement it is when you respond, you automatically put in the location header, you send back a location with the URL of the new resource you've created. That's the most elegant and best way to use the location in HTTP. But anyway, coming back to this location, what I can do here is I can say get index call response text. Now what is index and what is get? Get is exactly the same as the other get, except it's a different version. This one is a generic type of get. And what I pass in there is the location. So here I'm saying index. Now index is defined up there. So I've created this location / class index. And notice that this is lowercase because this isn't a real class. We're using the construct of a class to indicate location, so you follow the convention of lowercase. In this case, I'm saying employee ID, a root parameter ID, class employee, and now notice that this root parameter is the same as the property being passed in to the class, meaning that now I have static typing and direct access to that property of the root, as opposed to saying call.request.parameters and then curly square brackets ID. Now I have it statically defined. So you still have to create a string, but you only have to write that string once. Anywhere else, you just simply use the generic versions of get, post, put, delete, patch, option, etc., and you get access to this information. So if we were to run this, and we're going to do employee ID, so we do employee 30, you see that I get back my 30 just as before. Okay? So this is a much nicer way to actually define your locations, because it's refactor friendly, you define it in a single place, and you get that nice static typing to access the different root parameters. Next, async. So, Ktor is built from the ground up using coroutines. And essentially, when you call a request, if that's a fast processing, it's absolutely fine. Right? It's going to scale up, and you're going to be able to do multiple requests, thousands of requests, etc. It's absolutely fine. What happens, though, if you have a very long-running process? Something that is going to essentially block that request thread. Now, generally, the thing that we said is, look, really don't worry about that, because we'll still try and prevent the locking from happening. Because, I mean, with any server, the number of requests are limited. So if I have a long-running process, that's going to prevent another request from coming in. However, a much safer approach for everyone is for you to just follow certain guidelines. And here what we do is, essentially, I have my application where I'm installing my default headers. And then I have this respond to handle long calculations. So essentially what this is some very resource-intensive long calculation that's going to take place, which means that if I bombard this with 10,000 requests, it might end up blocking and not being able to process more requests. And then I respond with the value. Now this is not going to have that problem for one simple thing. Notice, with context compute. That's coroutines. So essentially what you do is that you put your long-running process code in with context, and then there's different contexts that are available in coroutines. There's the I/O, there's the compute, etc. And that basically guarantees that you are not blocking new incoming requests, because that's going to go and launch on a different thread, a different coroutine, and that's a suspending function, so you can do that. That's why you can do with context, because this is a suspending function. If you are familiar with coroutines, then you generally see how this works. If not, take a look at coroutines, but this is essentially the pattern, right? So, whereas with coroutines, with as threads, you can't launch 10,000 threads, you can launch 1 million coroutines. Okay? So that would be the approach that you want to take for really long-running processes that are going to consume some time. But generally, you want to always kind of avoid long-running processes. Now, what about testability? Well, with Ktor, you don't really test your applications because they always work. Thank you very much. No. So, Ktor basically abstracts the entire pipeline away, so you don't need to boot up an entire application server with the request response, all of that. You don't need that live HTTP sockets endpoints. You can essentially still test your application, test all the logic, test all the routing, test all of it without having to boot up this application server. It is always recommended and always nice to have integration tests that do it all, but generally for testing your routing, entries, etc., you can do that without having to have the overhead of an application. So here, for instance, I have testing, and I just have a property called testing boolean equals false, and I do routing get respond text just like we did before. And in my test, I do with test application, I pass in the property true, and then I do handle request. I make sure this is basically requesting a get with slash, and then I make sure that it gets back the results intended. Okay? So very testable from the ground up. And that gives you kind of like a brief overview of some of the features of Ktor, what you can do with it, how ready it is. We already have a lot of people that are using Ktor in production. We're using it in production. Again, I earlier mentioned that there's a product that we're working on that hasn't been released yet that is using Ktor on the back end. So you can deploy to all different cloud providers. You can deploy to Google Cloud Platform. In fact, I think that there's a code lab today of maybe even showing this, but definitely there's code labs online. So to just summarize a few other things, going back to our slides over here. Now, Ktor comes with different deployment options. Most of the examples that you've seen, I'm basically launching Netty. Right? But you can actually have development during Netty and deploy to Tomcat, Jetty, whatever you want. CIO is Chief Information, no it's not. CIO is coroutines IO. And this essentially is our implementation of, without Netty, Jetty, or anything else, it's basically completely IO, completely based on coroutines. However, it is a star, it means it is way from production ready. It's something that we're aiming to do, but it's way not production ready, so I do not recommend that you use CIO and then complain, oh, this is really slow. Containers, Tomcat Jetty, supports Java 6 through 11. I'm pretty sure that it probably supports Java 12 as well, and given the rate at which Java is coming out, I can update this and say probably Java 13 as well, and by the time I do that, Java 14's come out. And how many of you are using Java 12? 11, 10, 9, 8, there you go. Yeah, no, sorry. Google App Engine, Heroku, Docker containers, all of them are supported. It's actually very, very slick to deploy on Google App Engine. At I/O, myself and Ray had a session where we live coded a backend server in Ktor for a mobile application. That code is on GitHub. You can see it. It's deployed to it deploys to Google App Engine, so it's essentially a photo browsing app, and it was very easy to do. Okay, if you want more information, go to ktor.io, and if you want to start playing with it, go to start.ktor.io or download the plugin, except download the version that actually works, not the one that I have, and you should be good to go. Thank you very much.